Hey everybody, this is Dr. O. In this little video, we're going to talk about basically how enzymes function and how inhibitors inhibit enzyme function. So here we have an enzyme kind of shaped like a key because we know that they're all real specific about what kind of molecule they're going to work on. It's all dependent upon shape because that's the nature of proteins. And then up here we have a substrate, which is the molecule that we're going to be working on. And the thing we know about enzymes and substrates is that they have to come together, and there has to be some sort of reaction that occurs, and that in this case we're going to take a large molecule and break it up into two smaller molecules. So this is an example of a catabolic reaction. This could have just as easily been an anabolic reaction. But the thing that's important for us to understand is that we have an enzyme with a specific shape and a substrate that will fit into that shape in order for the reaction to be expedited. So how can we stop this reaction? Well, Mother Nature has provided us a couple of ways, so let's have a look. Now, one of the ways that we can inhibit enzymatic function is by putting something in the active site that basically occupies it so that a substrate can't fit in there and be worked on. And this is what we would call a competitive inhibitor. So a competitive inhibitor will come along and it will occupy the active site, and our substrate doesn't have any place to go, and then as a result we don't have a reaction. So what else can we do? Well, we got another option, so let's take a look at that. Now, instead of attaching something to the active site, we could attach something elsewhere to the enzyme, because keep in mind enzymes are proteins, and the functionality of proteins is dependent upon its shape. And if we can attach something elsewhere to the enzyme, we can alter the shape of the enzyme and very likely render it non-useful. I'll say it that way. And when we do that, that's what we would call a non-competitive inhibitor, because it's not attached to the active site, it's attached elsewhere. And if we attach something elsewhere to the enzyme to prevent an enzymatic reaction, we would call that spot the allosteric site. So an allosteric site is somewhere other than the active site where we attach some sort of a molecule that will disrupt the active site. So what is this non-competitive inhibitor going to do to our active site? Well, let's have a look. So as we just saw, we have now altered the shape of the active site by attaching that non-competitive inhibitor so that when our substrate shows up and tries to bind, it no longer fits. Okay, so the non-competitive inhibitor is going to attach a molecule elsewhere, and we call this elsewhere the allosteric site. Now, while we're on this topic, I want to point out something. So I said earlier that our proteins are functional based upon their shape, and that if we alter the shape with a non-competitive inhibitor, we thereby render the enzyme no longer functional. If we put our enzyme in different solutions, we might accidentally render the enzyme non-functional. So how does that work? Well, what if we put it in an environment that's too acidic, which means we have an abundance of hydrogen ions? Hydrogen ions could also attach elsewhere to the enzyme and render the active site no longer functional. That's a possibility. Or we could put our enzyme in a solution that is too alkaline, and you could have those hydroxide ions doing the same thing, attaching elsewhere to the enzyme and thereby altering its shape and rendering the active site no longer functional. If we heat our enzyme too hot, we alter the shape and render the active site no longer functional. So these are not examples of non-competitive inhibition, but since we're talking about non-competitive inhibitors and how they alter the active site, I just wanted to throw in that we can also alter the active site depending upon the pH of the environment, as well as the presence of various ions. They too could attach to our enzyme and alter the active site. So just wanted to talk a little bit about that. And with that, we are done. Thanks for watching.